Hi everyone, in this video I'll be looking at chapter 5 worksheet 2, how do we solve exponential equations using this substitution method. Okay, so what is substitution? Essentially, in worksheet 1 we learn how to solve exponential equations by making them the same base. So this substitution here is in the case whereby I cannot just make them the same base. So therefore I need to find a suitable substitution to simplify the equation before we solve it. Okay, so for example, let's say if I were to look at this simple equation over here, if you observe this equation here, there is no way I can make this exponential equation such that I have both sides of this equation here, they have the same base. So therefore, the only other method to solve this equation here is to use substitution. So what is substitution? It is essentially I am replacing an exponential expression, let's say 2 power x, by a simple letter u. Okay, it can be any letter, but I'll just use u. Okay, and I turn any exponential expression into this form here. So let's look at example 1. We need to first understand how do we use substitution. How do I change any exponential terms in terms of u. So for example 1, let's say if I let u be equals to 3 power x, how can I turn all these different terms into something in terms of u? Okay, so let's look at 3a, example 1a. Okay, 3 power 2x. First, I must extract out the 3 power x first. So by a loss of indices, this is simply equals to 3 power x, the whole thing power 2. Okay, if I were to open up the bracket and expand, I'll get back this. Okay, and therefore, this is simply equals to u squared, since u is equal to 3 power x. Okay, let's look at part B now. Part B, I have 3 power x plus 2. I can simplify this to become, by your loss of indices, this is the same as 3 power x times 3 squared. Therefore, I replace 3 power x with u. This is simply over here u times 3 squared, which is 9. And final answer is simply 9u. So if you observe, right, 3 power x plus 2 can turn into something much simpler, which is 9u, by using substitution. Okay, so let's quickly finish up these parts. All should be quite simple if you are strong in your loss of indices. This over here is equal to 3 power 2x divided by 3 power 1. Okay, therefore, I can simplify this to become 3x, the whole thing square, over 3. Therefore, I can simplify this to become u squared over 3. And this is for part C. Okay, let's look at part D now. Part D here, 9. So if you observe, right, this base here is 9, but I'm given u equals to 3 power x, which means that I need to extract out 3 power x from here. Okay, so what can I turn this? How can I turn 9 into base 3? We know that 9 is simply 3 squared. So this is simply 3 squared, the whole thing power x plus 1. Open up the bracket, I'll get 3 power 2x plus 2. Continue to simplify. I can break this apart to become 3 power 2x times 3 squared. Okay, continue to simplify. I can simplify this to become 3 power x, the whole thing square, times 9. Therefore, final answer is simply u squared times 9. Final answer is 9u squared. Okay, and this is for part D. Let's now look at part E. Part E over here, 3 power 1 minus x. By a loss of indices, this is simply 3 divided by 3 power x. Therefore, this is simply equals to 3 over u. Okay? Then last one, part F. If I have 3 times 9 power x minus 1, okay, remember, in order to use the substitution u equals to 3 power x, I need to turn this 9 into something which has base 3. So we know that this is equal to 3 times, I know that 9 can be rewritten as 3 squared, then the whole thing power x minus 1. I continue to simplify. This is 3 times 3 power 2x minus 2. Continue to simplify. We know that this is the same as 3 times 3 power 2x over 3 square. Okay. Therefore, I can simplify this. This is continue to simplify. This is simply equals to 3 times 3x the whole thing square over 3 square. Okay. 3 can cancel out on my numerator and denominator. I'm left with 3 in the denominator. Final answer is simply u square over 3. And that is it for part F. Okay, so this is a simple example to learn. Now, given all these terms here, how do I extract out the u given a given substitution over here? Okay, and this will be very useful when we start to solve equations that we will need to solve by using substitution. So let's now look at example 2. Example 2 here, use this substitution u equals to 2 power x to express this equation as a linear equation in u. So what does that mean? Okay, so that means that I must use a substitution here, u equals to 2 power x, and find a way to get rid of all these exponential terms here and get a linear equation in u. Linear equation means that the highest power of u is 1. Okay, so how do we do that? Let's look at part 1. I write out the equation here first so that we don't get confused. Okay, 3 times 2x minus power x minus 1 equals to 2 power x plus 4. Okay, now I see I can get a u here. Over here, I must do something first to make it easier. So over here, what I can do is that I break apart these indices. 3 times 2x divided by 2, okay, equals to 2 power x plus 4. Then from here, I can replace all 2 power x by u. I should get 3 over 2u equals to u plus 4. Okay, and therefore, this is the linear equation in u. This is for part 1. Part 2. Hence, solve this equation. So by making use of this part here, to solve this equation, very simply, I will make u the subject here first. So I have 3 over 2u equals to u plus 4. I shift all terms with u to the left side. This is 3 over 2u minus u equals to positive 4. Therefore, this means that half u is equal to 4, u equals to 8. Okay, therefore, since to solve this equation, when the question tells you to solve, you are supposed to find the value of x. So over here, now I found that u equals to 8. I can now replace back this u by my substitution, which is 2 power x is equal to 8. And I know that 8 is equal to 2 power 3. So 2 power x is equal to 2 power 3. Therefore, same base, I can now compare the power. Therefore, x equals to 3. And this is for example 2. Okay. Okay, let's now look at example 3. Example 3, using a appropriate substitution, solve this equation. I have this equation over here. Okay, if you observe this equation, one simple substitution I can simply use is let u be equals to 4 power x. Since I know I have a base 16 here, and 16 is 4 square. So over here, I'll write let u be equals to 4 power x. Okay, so over here, I start with the equation here first. 2 times 16 power x equals to 5 times 4 power x minus 2. Okay, I will first manipulate this equation such that I can get 4x, 4 power x. I know that this is the same as 16 can be rewritten as 4 square, the whole thing power x. Okay, equals to 5 times 4 power x minus 2. Okay, and over here you can see that this can be rewritten as 2 times 4 power x the whole thing square. It is the same meaning. Okay, because when I were to expand out, this will be 2 times x. I can flip it around. This is simply x times 2. Okay, equals to 5 times 4x power x minus 2. The reason why I want to do this is because I want to extract out a 4 power x for my substitution. Okay, then now I have 4 power x. I can now replace all 4 power x by u. I will get 2u square equals to 5u minus 2. Then from here we have a quadratic equation. How to solve quadratic equation? From here you can see that this is a quadratic equation in u. Highest power of u is 2. So if you recall from Sec 2, how to solve any quadratic equation? First make right hand side 0. I will get 2u square minus 5u plus 2 equals to 0. Then from here I can do my simple factorization using either your cross method or tic-tac-toe method. I should get factorize expressed into something times something equals to 0. I should get 2u minus 1 and u minus 2. Okay. Therefore, from here, how to solve for u? I should get 2u minus 1 equals to 0 or u minus 2 is equal to 0, which gives me u equals to half or u equals to 2. Okay, but take note, this is not the answer to the question. When the question says solve this equation, solve means that I want to find the value of x. So over here, I will only found the value of u. I can compare to my u substitution. U is 4 power x. So by replacing this, I have 4 power x equals to half or 4 power x equals to 2. Okay, then we go back to solving exponential equations. We make them the same base first. I can see that I can turn this into base 2. So over here, 4 is 2 square. 2 square power x, half is 2 power negative 1, which means that 2 power 2x is equal to 2 power negative 1. This, therefore, by same base now, I can compare the powers. 2x is equal to negative 1. X equals to negative half. Okay, I do the same thing for the other side. 4 power x equals to 2. I can make them the same base. This is 2 square the whole thing power x equals to 2. Therefore, 2 power 2x is equal to 2. I compare, same base now, I compare the power. 2x is equal to an invisible 1 over here. So therefore, 2x equals to 1. Did I miss out negative on this side? I just realized I missed out negative. This one should be negative half. Here should be x equals to half. Okay, and there you have it, your 2 answers for example 3. Okay, let's now look at example 4, the last example for this worksheet. Okay, the steps are similar. Using the appropriate substitution, solve the equation here. Okay, so let's write down this equation here to be clear first. Example 4, you can try this by yourself if you want to. Okay, then you can just pause this video, then come back once you have tried this question. Okay, so for this question here, 4 power negative x plus 4x plus 1 equals to 5. Easy appropriate substitution is simply let u, well, I'll write this at the top. I'll let u be equals to 4 power x. So that means from here, we will find a way to manipulate this equation such that I can extract out a 4 power x. So I can see that from here, 4 power negative x can be written as 1 over 4 power x plus, here I can split apart by my loss of indices. This is 4 power x times 4 equals to 5. Okay, therefore if I have to sub in my u now, I will get 1 over u plus 4u equals to 5. Continue solving from here. I want to get rid of this fraction. I will multiply u throughout the whole equation. Multiply u throughout the whole equation on the left side and right side. This is where a lot of you may make careless mistakes. When I multiply u on the left side, I'm multiplying u to each single term. So therefore, 1 over u multiplied by u, I should get 1. 4u squared multiplied by u, I should get 4u. 4u multiplied by u should give me 4u squared. Then the right side, 5 multiplied by u should give me 5u. Okay, and now I get a quadratic equation in u. How to solve quadratic equation in u? Steps are the same as step 2. Make right hand side 0. So by rearranging the equation, I should get 4u squared minus 5u plus 1 equals to 0. Then from here, I continue to simplify by factorization. I should get, factorize this, I should get 4k minus 1 times k minus 1. Okay, which will give me 4k minus 1 equals to 0, or k minus 1 equals to 0. Then from here, we can solve for k. K equals to 1 over 4, or k equals to 1. But remember, question here, solve this equation means I want to find x, which is the unknown in the original equation. So over here, by going back to this, 4 power x equals to 1 over 4, or 4 power x equals to 1. Over here, by we are making the same base, 1 over 4 is 4 power negative 1. Therefore, x equals to negative 1. And on the right side, 4 power x equals to 1. Anything power 0 is always equal to 1. We can therefore conclude that over here, 4 power x is the same as 4 power 0. Therefore, x equals to 0. And with that, I have solved the question to find the two values of x over here. Okay, so now you can pause the video first. Go and do the practice questions from your textbook. There's 3 practice questions. Then once you have done the practice questions, you can continue playing this video to see how I solve the practice questions before you start on the assignment questions. Okay, alright, so this is the first practice question, question 4. Okay, please go and complete these practice questions by yourself first. Once you are done, then play this video to see the solution for this practice question. Okay, so let's start. Practice question, question 4 from exercise 5.1. Okay, use your substitution u equals to 3 power x to solve this equation here. The steps are the same. If I want to use this substitution, I must manipulate this equation to obtain 3 power x. So from here, I can rearrange this equation. Maybe I'll use a different color so you can see clearly. Okay, 3 power x equals to 4 minus 3. I know that I have a 3 power negative x here. So what I should do is that I will turn this into 3 power x by flipping this. This will become 1 over 3 power x. Then I continue to simplify. Therefore, I replace 3 power x by u. I should get u equals to 4 minus 3 times 1 over u, which is the same as u equals to 4 minus 3 over u. Okay, to get rid of this fraction, I shall multiply u on both sides of the equation. So the left side multiply by u. Right side, I also multiply by u to the entire right hand side. Left side, I should get u square. Right side, multiply u to both terms. 4 multiplied by u will give me 4u. Negative 3 over u multiplied by u will give me negative 3. Therefore, I have a quadratic equation in u now. I just need to solve this as usual. So therefore, make right hand side 0. U square minus 4u plus 3 is equal to 0. Therefore, by solving this by factorization, I should get here u minus 1 times u minus 3 equals to 0, which will give me u equals to 1 or u equals to 3. Okay, therefore, since I know that u is equal to 3 power x, this means that 3 power x is equal to 1 or 3 power x equals to 3. Therefore, to make them the same base, 1 is 3 power 0. I will have, therefore, x equals to 0 or x equals to 1. This is an invisible one here. Okay, and this is the answer for question 4. Alright, let's now look at the next question, which is question 8a. Okay, question 8a now. Solve this equation. The question didn't tell you what substitution to use, but I hope it's clear to you that you will use a substitution. Let u be equals to 5 power x. Remember to state what letter you are using and for what substitution you are using clearly. Okay, so over here, solve this equation. I will first extract out 5 power x from here. I do not see a 5 power x here, but 5 power 2x. So by rewriting this equation, I should get 5 power x, the whole thing square, minus 6 times 5 power x plus 5 equals to 0. I now replace the 5 power x by u. I will get u squared minus 6u plus 5 equals to 0. Therefore, I have a quadratic equation now. Now simply solve this by factorization. I should get u minus 1 times u minus 5 equals to 0. Therefore, u equals to 1 or u equals to 5. And therefore, 5 power x equals to 1 or 5 power x equals to 5. Therefore, very simply, I know that 1 is equal to 5 power 0. Therefore, x equals to 0 or therefore, x equals to 1. And this is the solution to question 8a. Okay. Now let's look at the last practice question, question 9b. Okay, question 9b here. Okay, if by now you should be quite good at this already. To use a substitution, I hope it's clear to you. Over here, the clear substitution to use is 7 power x. So that means from here I must extract out a 7 power x. Alright. Let u be equals to 7 power x. Then I rewrite this equation here. 7 power x plus 1 is the same as 7 power x times 7 minus 2 equals to 2 times 7 power x plus 3. Then I'll get 7u minus 2 equals to 2u plus 3. Therefore, simply solve this linear equation. I should get 5u equals to 5. And therefore, u equals to 1. Therefore, solve this equation means solve for x, which means that 7 power x is equal to 1 and 7 power x is equal to 7 power 0. Therefore, x is equal to 0. Okay, so this is the solution to the practice questions for this worksheet. Once you are done, you can now start on the assignment questions. And that will be the end of this video.